So this will start and not freeze. There we go. On Thursday, you guys should have copied down some basic probability stuff. I think that I'm going to go through this kind of quickly because a lot of you, this is a review of like middle school concepts and early algebra 1 stuff. If you haven't done this yet, then you just go through into the pair deck. The notes are there, and you guys can still finish it. I extended the deadline for today for this to be turned in by the end of the day today for your class. So if you haven't done it yet, you have an opportunity to finish it without a late grade. So go make sure that I think almost all of you in here have done it. And I think most of you guys online that are here right now have already done it. So you guys are good. The probability stuff is not new to you guys, but what I'm trying to introduce to you is the notation of probability. The notation is something you probably haven't seen before, where it says where you have the P and you put the event of what it is that you're looking for inside the parentheses. That is new. And the stuff that I'm going to be going over is stuff that you might see in an introductory statistics class in college. Okay, so it's not hard, but it's not like elementary either. The new thing that you might not have seen yet, I'm going to hide this, is this C thing right here. Let me use a different color. The C stands for the complement of an event, meaning it's the probability of something not happening. Keep that in the back of your mind as we go through some of the new things today that you'll see here. Did anybody have any problems with the two-way tables? Have you seen tables like this before, where you add up everything in the same column and you get the total there at the bottom? So, for example, this right here is added up together. 3 plus 5 is 8. But also this right here is added up together. 6 plus 3 is 9, and that's where the total comes from. The total in the bottom right corner is always the total of the rows and the columns together. Okay. So that's what this practice got you guys through. And I want to go over the ones at the end. Did anybody have a problem completing this table? Okay, so really quickly, just so you guys all have it, in order to fill out a two-way table that's not complete like this, we need to work backwards. We know that this 20 is a total of all three of these together, meaning that 7 and 3 is 10. So this blank right here has to be 10 because 7 plus 10 plus 3 is 20. All right. So that was the first blank that you were missing. Now I can fill out this section here, the oak section. 10 plus 16 is 26, and I know the total's got to be 34, so this has to be 8 right here. Working backwards, now I can figure out the total of all the large ones. 8 plus 2 is 10. The total is 14, so that means that this has to be 4. And then working across here, 7 plus 4 is 11. That means that plus 12 more gives me 23. What's the total down here for the medium? What'd you get, Claudia? 36. And the total for everything? 70. Okay, good. Take a moment to kind of take a look at that. I'm going to move forward to give you the correct fractions for these. I'm not going to give you the decimals. I'm sure you guys can divide them out in your calculator. And for number 1, the probability of a large oak bookcase would have been a 8 out of 70. So 8 divided by 70 should have been your fraction for the first question. Any questions on that? You guys get that? Okay. Number 2, medium bookcase. It doesn't specify what type of medium bookcase. So it doesn't say pine, oak, or yew. So we should use the total, which is 36. So the fraction for number 2 should have been 36 out of 70. Questions on that? Number 3, it says a yew bookcase. It doesn't say what size. So again, you're going to use the total. So it should be 13 out of 70 for that one. And the last one is the one that's going to be a little bit different. So it says the probability of a medium pine bookcase, but it has that C at the top. Okay. A medium pine is 12 out of 70. but that C means the probability of that not happening. Okay. So on number 4, this should be, gosh dang it, I hate this thing. It should be 1 minus 12 over 70 is the probability of that not happening. Okay. You can't see that, can you? Let me change the color. It should be 1 minus 12 over 70. Okay. Remember, that is the complement. And again, I know this was just a starting out. Okay. This was a completion grade. We're going to do a lot more of this today. It'll make a little bit more sense when I show you a different idea. Okay. A different idea than a two-way table. Okay. So those are the 4 answers to the 4 practice problems. Again, completion grade. If you haven't uploaded it, take a picture of your notes in those 4 problems and upload it to Schoology before the end of the day. Okay. All right. Don't forget to submit your homework. For you guys at home, here's what we're going to do today. We're going to start in some new notes. So make a new section on your notes section. You guys call it 4.2. It's Venn diagrams. It's going to roll through this pretty quickly in terms of some of the stuff. I don't want you to write down everything. I want you guys to soak it in and just look at. I'll tell you what I want you to write down. And if you ever need to go back to look at the examples, I've already embedded the notes here into the folder. Okay. So don't worry about writing a bunch of stuff down until I tell you to do so. You guys doing good at home? All right. So again, don't write any of this down. You can label a new section. I'll tell you when to write something down. Label it 4.2 Venn diagrams. You guys know what a Venn diagram is, right? You've done Venn diagrams before. Okay. Have you done it with math before, or only like English and comparing two things? You ever done a Venn diagram in math? No? Yeah? What class did you do? Do you remember? In geometry? Algebra 2, you mean, right? Yeah. Okay. All right. Don't write this down. I want you guys to only have your cell phone calculator out, or you can grab a calculator in the back. Somebody stole a calculator again. I don't know who took a calculator home. We're going to do some really, really basic calculations, literally dividing 2 numbers. Okay. Rolling a dot. We're going to start probability when the most basic of probability. There's the most basic probability of things: flipping a coin and rolling a die. Okay. Die is just the singular of dice. And tell me, or put this in your calculator, or tell me what the fraction would be. Don't write it down. What's the probability of rolling a 2 on a die? You don't need to write anything down. Tell me what you think the probability of rolling a 2. 1 out of 6. Do you guys agree with that? There's 1 2 on a die, and there's 6 sides. The probability is 1 out of 6. Okay. Divide 1 out of 6 on your calculator. 1 divided by 6. What is the decimal version to 3 decimal places? What's the answer to 3 decimal places? Point what? 166. What's the number after the 6? 6. So it's 0.167 would be the correct rounding. Okay. So 0.167. When you do probability, you can write it as a fraction. You can write it as a decimal. Or you can write it as a percentage. If I want to change that decimal to a percentage, I multiply by 100. What would the percentage be? 16.7%. Okay, you could just move the decimal place over 2 times to the right. All right, 16.7% chance of rolling a 2. We go pretty easy, right? Let's do another one. What's the probability of rolling a 5? It's the same thing, right? There's only 1 5 on a die, 16.7%. Okay, I'm not trying to trick you, but I'm showing you. I'm going to show you something. Now, look at the way I worded this question. What's the probability of rolling a 2 or a 5? Tell me the it's easy to tell me the fraction. A 2 or a 5. I roll a die. Probability of 2 or 5 showing up. What are my options here? I have 2 or 5. There's 2 different options. Out of how many total solutions? There's still only 6 solutions, right? There's only 6 sides on the die. So there is 2 out of 6, which is 0.333, repeating with 1/3, 33.3%. Well, another way I could have done that, we could have added the 2 previous answers, right? 1 out of 6 plus 1 out of 6 is 2 out of 6. Okay, so this is one way to answer this question, adding the 2 previous solutions. Okay, but be careful of the wording. I said or. Different problem. We already know this answer. What's this answer? Probability of rolling a 4. Still 1 out of 6. There's only 1 4 on the die. Now, what's the probability of rolling an even number? Alyssa, what do you think? 3 out of 6. You guys agree? Okay, there's the 2, a 4, and a 6. And those are all even numbers. Are the only even numbers on there. 3 out of 6. What percentage is that? 50%. Yeah. Okay, 0.5 to 50%. All right, I'm going to show you the next question. And I want you to think really hard about it before you yell out an answer. Okay? And maybe I should call somebody at home about this one. Okay? Here's the next question. Think about it. What's the probability of rolling a 4 or an even number? Think about it. Don't say anything just yet. Anybody at home think they might have an answer to this question? What's the probability of rolling a 4 or an even number?
Because it's an even number still?
3 out of 6 because it's still a 4 is already an even number. We can't just add the last 2 problems. We can't add the 3 out of 6 plus the 1 out of 6. Why not?
Because it's not even.
Because
It's not another 4.
there's not another 4 on the dice, right? 4 is already an even number. Okay. Here's a term that you will probably heard of before. You probably didn't know what that means. Okay. Have you heard of the term mutually exclusive? 2 things are mutually exclusive if they can happen at the same time. Rolling a 4 and rolling an even number are not mutually exclusive because they can happen at the same time. So we can't just add those 2 probabilities together. The solution is still 50%. There's still 3 solutions out of 6. What's the probability of rolling a 3 and an even number? Think about this one before. Four out of 6? Why?
Because there's 3 even numbers.
There's 3 even numbers.
The third number.
And then
3 is odd.
And 3 is the other solution, right? Do you guys agree? What about you guys at home? Let me get somebody to answer from home. Do y'all agree with 4 out of 6? Rolling a 3 and an even number. Miranda says it can't happen at the same time. Do you guys agree with that? Is it possible to roll a 3 and an even number at the same time? So when the question asks rolling a 3 and an even number, if it's not possible, what's the probability got to be? 0. Okay, it's got to be 0. Rolling a 3 and an even number are mutually exclusive. It means they can't happen at the same time. Anything that can't happen at the same time has a probability of 0. Okay, so you're right, Miranda. How would I change this question, Alyssa, now that you answered that? What would I change in this question to make this the answer that you gave me, which was 4 out of 6?
You had 2 dice.
What?
You had 2 dice.
Okay.
What if you change
It would change the answer. But you're right, that's one way. But the answer wouldn't be 4 out of 6 still. Say it, Claudia.
What if you change and?
That's exactly right. You would change and to or. If we changed and to or, it would say, what's the probability of rolling a 3 or an even number? Now your solution is correct. Now it's 4 out of 6. But the fact that we wrote that and in there, it makes it incorrect. Okay? Makes sense? You see this wording here? All right. Not having you guys write anything down until now. All right. So I want you to write down these rules. Okay? I got 4 bullet points, and these are the only things that you're really going to write down for your notes. The first thing is this right here. So write it down, and I'm going to explain it. Okay? I'm getting you guys into the like I said, to getting used to writing down the correct notation for probability. The writing down the notation for probability where it talks about A or B, we use this thing called the union symbol. Okay, and it's called union not because it looks like a U, but because I'll show you when it'll make a lot more sense when I show you on a Venn diagram. Okay, but this is called the probability, the union of A and B, the probability of A or B happening. This right here means or. I keep using that red color. Use a different color. Okay, this right here means or, and it's already written out there. So A or B. This is the way that you're going to see the notation written from now on probability problems. Okay. Now the next notation I'm going to give you is the probability of A and B. I do one simple thing with this symbol to change it to be and. What do you think I'm going to do with that symbol? Turn it upside down. That's exactly right. Okay. We just turn it upside down, and now it's called it's a probability of A and B happening. This is called the intersection of A and B. And again, when I show you this on Venn diagrams here in a minute, it's going to make a lot more sense about why it's called the union and the intersection. Okay. Let's see. Lizzie's here today. Gustavo. Gilbert. Okay. And then the next note is what I talked about with mutually exclusive. Think of 2 things that are mutually exclusive, meaning that they cannot happen at the same time. You flip a coin, you cannot get a heads and a tails at the same time. It's just not possible. Has anybody ever flipped a coin and it landed on its side?
I've seen it happen.
You've seen it happen before? Really? Well, even if you flipped a coin and it landed on its side, let's say that's even possible. I'm sure it's possible. I'm sure it's happened before. Is that still getting a heads or a tails, though? It definitely isn't going to be considered getting it both, right? So that's not possible. Somebody gave this example in last period, and I thought it was hilarious. It's 2 things that are mutually exclusive: sneezing and having your eyes open. Are sneezing with your eyes open mutually exclusive? Can you do those at the same time?
Unless you have a weird condition.
I don't know. I think I always close my eyes when I sneeze. I don't know about you guys. What else? Like, what are other things that are mutually exclusive? What are 2 things that you can't do at the same time? Give me some crazy oddball things. Can you take government and economics at the same time?
No.
You could, right? I know some seniors that are taking it both right now, and they're just going to have an off period semester, right? So government economics is not mutually exclusive. Now, can you take English 1 and English 2 at the same time? Unless you're repeating one of them as a sophomore, then no. You can't be a freshman and take English 1 and English 2. You got to finish English 1, and then you got to take English 2 the next year. Okay, English 1 and English 2 are mutually exclusive. They cannot happen at the same time. Okay, so those are those things that there are going to be a lot of examples of that. And then here's the last thing. This is the last little note. I want you to write this rule down. The rule will make a lot more sense at the very end when I'm done with the Venn diagrams to show you. But here's the addition rule in probability. The probability of A or B is just the probability of A plus the probability of B, but minus them both happening at the same time. Okay. So again, I'm gonna circle back to that rule, but I want you to already have it in your notes. Okay, you guys good? Does anybody need more time? Okay. Now, on the next couple of slides, I'm going to go over some examples. You don't need to write any of these down. You can always go back to your to these notes if you need to. However, I'm going to probably have you just copy down really quickly the Venn diagram on the next screen, so you have it on your paper in front of you. Okay. Maybe got it? Okay. And Ethan's almost done. Good? Okay. All right. Really quickly, doesn't need to be super fancy. Draw two ovals, put those two numbers in there and put algebra 2 and chemistry, or just A2 and C on one side to have a Venn diagram. And let's talk about it. Okay. Ms. Snow conducted a survey of her homeroom. Okay, homeroom's like advisory. She asked students what math course and what science course they were taking this semester, and these are the results. Okay. Again, don't be super fancy. Just put the two ovals, put the rectangle around it, put the four numbers. Okay. On a Venn diagram, we are going to always have four numbers. There is, I guess I should do this on here so that you guys can see it too. Okay, so there's going to be a number in this oval. There's going to be a number in the middle of the two ovals on this side, and then there's a number on the outside. Okay, let's talk about, it says jot down some facts. Let's just talk about some facts about this homeroom. You don't need to jot anything down. Let's just talk about it. So first of all, first question, see if you can just answer this out loud. You don't want to write this down. How many students are in Miss Snow's homeroom?
Miss Snow?
Yeah, Miss Snow. 29. How'd you get that, Draven? Add all the numbers up. All right. You guys agree? There's 29 students in the homeroom. All right. I'm gonna slowly get harder and harder. How many students take both Algebra 2 and Chemistry? Claudia says 4. You guys agree? Okay. We all know from way back, like what, 5th grade, that when these two overlap, whatever's in the middle applies to both, right? So there's 4 students to take both Algebra 2 and Chemistry. How many students take neither Algebra 2 nor Chemistry?
6.
There's 6. There's 6 students that take neither one of them. Otherwise, they would be in either of these two bubbles. You guys agree? Yeah. All right. How many students take Chemistry?
No.
What do y'all think? 9. Why is Jill correct? Because both of these take Chemistry, all right? So we have to add the middle to the ones on the side in order for that answer to be correct. Now let me rephrase my question. How many students take Chemistry and not Algebra 2? That's 5. Okay, so that's where the 5 comes in there. So be careful on the way the question is worded when you're doing these types of problems. How many students take Algebra 2 or chemistry? Anybody at home? How many students take Algebra 2 or chemistry? 23 is correct. Okay. Look, Algebra 2 or chemistry is everybody here. It's the 14 people, the 5 people, and even the 2 people, the 4 people that do both of them, they're still taking one or the other, right? Christian, I asked you, are you an AQR? What are you going to say? And if I ask you, do you play baseball? What are you going to say? And if I ask you, do you play baseball or are you an AQR? What are you going to say? You're still going to say yes, even though you're doing both of them, right? All right, so be careful when it talks about that. So now I'm going to move into the probability questions. You don't have to write these down unless you want to, okay? So help me find this answer, okay? If you want to write down that question, you can. That way you have these for your notes, but you can come back and look at these notes later. But help me figure out the fraction for this. Find the probability algebra 2. So first, what does this mean? Well, I wrote this down here. You don't need to write this down. Just this is what this means is find the probability that students taking algebra 2. What should my fraction be to help me figure out this answer? First of all, how many students are taking algebra 2? 18. In order to find the probability, I divide that by the total, which is 29. So my fraction is 18 out of 29. If you use your calculator, and like I said, I'm going to go through this pretty quick because I know you guys can divide 18 by 29. Okay, you get 0.621, which is 62.1%. Okay, pretty easy. All right, I got 4 more, and then I'll give you your assignment. Before we get an answer to this, tell me what this means. Probability of what? Look at your notes. Algebra 2 and chemistry. So we know this is algebra 2 and chemistry. Now let's narrow down on how many students that is. We already answered this one. No, and. 4. And means they have to do both. Okay. So 4 out of, not 23, 29 still, out of the total. Okay. 4 out of 29. And then when you divide that, this is what you get. Now go back and look at your notes again. The and is called what? What is that called in probability? Intersection. Notice how this is exactly where they intersect the 2 ovals. Okay, that's why it's called the intersection. Okay, so it's where they intersect. Make sense? All right, let me reword this next question. Watch what happens. This flipped. What is this now? This is or. Algebra 2 or chemistry. Now, Ethan, what is the fraction for this one? This is the 23. This is all of them together over here, not including the 6. So 23 out of 29. Okay. Now, go back and look at your notes. What was this called when it was or?
Union.
The union of A and B. Well, the union meaning I am combining everything. It's like I'm unionizing everything there, with the exception, obviously, of the ones that are not. Okay, so that's where the union comes from. All right. All right, I got 2 more. Tell me what this means first. Tell me what this means.
The ones not doing algebra and chemistry.
Say it again, Jojo.
The ones not doing algebra and chemistry.
The ones that are not doing algebra nor chemistry. Yeah, that's correct. So this is what it's the probability of not taking algebra 2 nor chemistry. Okay. So we can approach this one of 2 ways. We can take the answer from the last problem, because this is how many people are doing algebra 2 or chemistry. So I can take this number and I can subtract it from what? The whole, 100%, or 1 if you're using the decimal. So I can set it up like this. Or what's the easier way to do this? How many students are taking neither one of them? 6. And 6 out of 29 is the same answer. Okay, so there's 2 ways to approach these. When it's visual like that, I would probably not do the 1 minus. I would just find out how many there are that match to what you're looking for and divide it by the total. Okay, it's the easiest way to approach this. All right, take a look. Here's the last example. Take a look at where the C is right here. Okay, I'm about to pop up the last question. Well, these are all kind of like the different ones that you're going to see. What do you notice now? What's the difference? The C only applies to the chemistry. So what do you think this stands for? Christian, what do you think? Probability of algebra 2. What does this mean? And. But chemistry with the C means and not chemistry. So this is essentially saying, what's the probability of a student taking algebra 2 but not chemistry? Okay. How many students are taking algebra 2 and not chemistry? That's 14. Okay. So this is 14 out of 29. And of course, you can find the answer just by dividing. Okay. All right. Do you think these are hard? It's just going to take some memorizing of this notation. Okay. I was going to just the last thing I wanted to show you, and I'm going to pop it up here real quick. Obviously, algebra 2 and chemistry are not mutually exclusive. You can take algebra 2 and chemistry at the same time. How many of you actually did that? Took algebra 2 and chemistry the same year? Or did you take algebra 2 last year and then chemistry the year before? Or some of you took IPC first and then took chemistry, right? Anyway, what would a Venn diagram look for 2 things that are mutually exclusive? Like if you had English 1 and English 2, could that Venn diagram actually overlap? So what would it look like? Just 2 separate circles. And so this right here kind of ties back in what I was showing you with that formula. When 2 things are mutually exclusive, they can't happen at the same time. So you just add their probabilities together to figure out what it is for both of them happening. However, when they are mutually exclusive, you can't double count that middle. You can't just add A and B. You have to take out the middle. This is the middle right there. And that's why that formula looks like that. Okay. You don't need to worry about memorizing that formula because you guys are going to be doing it just by looking at the diagrams. Okay. All right. So those are your notes for today. What you guys, those of you guys that are at home, you can go into, let me share this again, Schoology, and you can get your assignment. Is that the right one? By clicking on 4.2 homework. And you guys here, I printed it out for you so you don't have to do it in your notes. Use your notes. One page front back, pretty short. So here's what I want to go over with you guys. And I'm going to keep this recording going so that at least people that watch it later can get some stuff. It should be all pretty straightforward to use your notes, but I'm going to help you guys with some of these Venn diagrams to make sure you have the Venn diagrams set up before so that you get some. So let's do a couple of these together. That way you have enough to do on your own. Okay. But let's start on the front page, especially with creating these Venn diagrams, because I think that's where a lot of people will get confused is, hey, you can't even answer these questions unless you created the Venn diagram correctly. So let's make sure you create it correctly. Somebody just logged off, so I guess they're going to not get any of these freebie answers. Okay. The first it says show your work by writing the answers as a fraction, a decimal, and a percentage. All you got to do is do the same way that we've been doing it on the examples. Here's a survey of a fourth grade elementary class. There are 30 students who are asked if they have a dog or a cat. Results are shown below. 21 students have a dog, 16 have a cat, and 8 students have a dog but not a cat. Create a Venn diagram. What's the first thing we should do with the two ovals? Yeah, one of them's got to be dog. One of them's got to be cat. Okay, so that's the first step. What number should I put first and where should it go?
16 students with a cat.
Where would the 16 go?
Cat.
You sure? What do you say, Javen?
Yeah.
Can I put 16 here? Why can I not put 16 here? Yeah, because the 16 is going to include the whole oval. So the 16 will include the two numbers that are right here total. So I can't put that 16 there. I can't put the 21 there. But I can put the 8 where? Underneath the dog. I can definitely put the 8 right here because it says 8 students have a dog but not a cat. That makes sense?
What about the 21 students that have dogs?
Okay, well, 21 students have a dog, or look at this. Are there 21 students total? So this whole bubble will be 21 when I add it up together. So now can I figure out what goes in the middle? Take 8 from 21, which is what? 13. Does that make sense now? Don't forget that the total, these two numbers have to add up to the total right here. So there's 21. 8 plus 13 is 21. Okay. Well, now that we know that there's 13 in the middle, how do we figure out how many people have just a cat? How many? Subtract 13 from 16, which is 3. What are we missing? The number on the outside. How do I figure that out? Add them together and subtract from 30. There's 30 total students. So 8 plus 13 is 21. Plus 3 is 24. Which means how many are on the outside? 6. And what do those 6 people represent? None.
Well, what do they represent?
Well, tell me what they represent. The people that don't have a dog or a cat, right? That's what those 6 people are. All right. Help me do number 2. Find the probability that a student has a dog or a cat. I'm going to write the correct notation on here. Make sure to write the correct notation as it help you with the rest of these problems. Probability of dog. And how do I write or? Is it the U or upside down U? It's the U. Dog or cat. That's the correct way of writing the notation. Now let's figure out how many people or how many students satisfy that. Do these 8 people have a dog or a cat? These 8 people don't have a dog or a cat?
Oh. Yeah.
Yes. Do these 13 people have a dog or a cat? Yep. Do these 3 people have a dog or a cat? Do these 6? No. So just add these 3 up, which is 24 divided by 30. And then you can use the calculator to finish the rest. So what did you get for the decimal? 0.8, which is 80%. Yeah. And especially if you guys are doing this in your journal at home, box in your final answer. It makes it a lot easier to grade your stuff. Y'all want to do number 3? Okay. Why would you say no, right? All right. Find the probability that a student has a dog and a cat. What's the only thing I'm changing from the last problem? The what? Well, what's the only thing I'm changing from the notation? The upside down U. I don't think I can do that on here. What? Okay. Good. That works, I guess, instead. That's not it's not an N, guys, for you guys at home. It's the intersection symbol, which is that upside down U kind of. All right. Thanks, Christian. All right. How many students have a dog and a cat? 13. 13 out of 30. I'll let you guys figure out the decimal and percentage on your own. If the decimal is long, put it to 3 decimal places. So tell me what it is for 3 decimal places when you divide it. So it's point what? 4 what?
No, I got 0.4333.
Okay, so 0.433. And then when you multiply by 100, 43.3%. That's correct. Just do these last 2 with you. Okay. Find the probability a student has neither a dog nor a cat. How do I do neither one of them? The C, but where does the C go when it's neither one of them? On the outside of the parentheses. Okay, so it's the U, but we put the C on the outside. I don't have to write this in. C goes right here. Okay. You all right, Ethan? All right, I'm not going to get through this one for you. You guys can figure that one out on your own. I just want to give you the correct notation. Last one here for the notation. Find the probability a student has a cat but not a dog. You only put the C next to the dog. So you put the cat first. So P, probability of cat. And it's the upside down U. So it's and, not the dog. And I'm going to write it in separately. So it's like this. And I'll let you guys figure out that one on your own as well. So those are the correct notations for those 4 problems. If you want to, I can quickly go over when you're done with that, the correct Venn diagram for number 6 so that you can answer 7 through 12 correctly. Okay. Do you guys want a few minutes to finish 4 and 5, or do you want to just do that right now? Just do it right now. Good, Claudia? Okay. Number 6, it says, a recent survey suggests that 72% of college students use Facebook regularly. 83% use Instagram, and 63% use both. First and foremost, let's label this Venn diagram. One of these should be Facebook. I'm just going to put FB. One of them should be Instagram. Y'all have both Facebook and Instagram, and Snapchat, and TikTok, and Twitter, and what else? MySpace. You still have MySpace? Was MySpace even around when y'all were born? Or like when y'all were, do y'all have MySpace when you were little? No? It's already phased out by then, huh?
Kind of.
MySpace, man. You never knew the struggle of MySpace. You had to pick like your top 8 friends, and like if you didn't put like somebody in there and they got all mad about it, man, the struggle was real. All right, which number can we put in first? Which number has to go first? The 63 for sure goes where? In the middle. It literally says 63% use both. So that one is for sure got to be in the middle. Okay. That's going to change those other 2 numbers because it tells you that 72% use Facebook. That means that this whole bubble has to be 72%. 63% is already in the middle. What does that leave out here on the outside? How much? What do you get? Well, we're just forget the percentage. So there's 9%. So again, for those who are unsure about where we got this number from, this total bubble is 72%. Well, 63 is already here in the middle. So 72 minus 63 is 9%. That's where that came from. Okay. Do the same thing on the other side. This whole Instagram bubble has to be 83%, but 63 is already in the middle. So what does this leave over out here? 20%. Is Jill the only one getting this? Okay. Again, I just want to reiterate, this together, all together, has to be 72. 63 plus 9 is 72. This all together has to be 83. 63 plus 20 is 83. Don't forget to do the one on the outside. Add all this up and figure out what's left over. What'd you get, Claudia? 92% total. So what is this number out here? What's the total got to be when we're talking about percentages? 100. So this has to be 8%. Whoops, why is it yellow? This has to be 8%. Okay. Now on these problems, what I want you to do, it says explanation. Write out in words what this means. Okay. And then find the solution like you've been doing it. Fraction, decimal, percentage. As you go, we will go over the correct answers for this on any questions you want me to go over on Wednesday. Okay, it's not due until the end of the day on Wednesday. So this is what you're going to work on right now. Help each other out, work on it. If you guys want to go over any answers, let me know.
Can you go over like 7 to explain what it means?